7.4, solving absolute value inequalities. When we solve absolute value inequalities, we want to make sure, once again, that our absolute value is by itself. Then from there, we form two inequalities. When we take the negative of that answer, we are going to make sure we switch the sign, just like if we were to divide that number or multiply that number by a -1. If we are keeping the number the same, it's just the sign's gonna stay, so your inequality sign will stay. So if we look at example A, we have the square root of the absolute value of x plus 3 plus 1 is greater than 4. So we're going to move the 1 over first by subtracting it from each side. We get the absolute value of x plus 3 is greater than 3. So this is a possibility, so we're going to rewrite this as x plus 3 is greater than 3, as well as x plus 3 is less than -3. We're going to move the 3 over for both of these by subtracting it from each side. So we have x is greater than 0 and x is less than -6. So again, we want to rewrite this as the x is less than -6 first because it includes the smaller number. And then x is greater than 0. We look at the way these two signs are facing. They're facing opposite of each other, or they're pointing opposite of each other. So this is a or statement. And then on our number line, we're going to have -6 and 0. We are going to have open circles on both of these numbers, and our lines are going to run away from each other. For B, we have the absolute value of x minus 2 minus 3 is less than 1. So we're going to add the 3 to both sides. We have the absolute value of x minus 2 is less than 4. This is a possibility, so we're going to do x minus 2 is greater than -4, and x minus 2 is less than 4. Get the x by itself, add the 2 to both sides. So x is greater than -2, and x is less than 6. Our two signs, or our two inequalities, the one that has the lesser number, that includes the lesser number, is on the left, so we're okay there. Look at the way your signs point. They point towards each other, so this is an and statement. We're going to rewrite it as -2, x, and 6. Then we have the sign that's facing the x, or open to the x, between the -2 and the x, so it stays open to x. Then between the 6 and the x, it's open to the 6, so it stays open to the 6. So from here, when we go to graph, we have -2, 0, 2, 4, 6. We have open circles on both the -2 and the 6, and then those lines are going to go in towards each other. So they're going to connect those two circles. For C, we have the absolute value of x plus 1 minus 4 is less than or equal to -2. So we're going to add the 4 to both sides. So the absolute value of x plus 1 is less than or equal to 2. Possibility, yes, x plus 1 is greater than or equal to -2. X plus 1 is less than or equal to 2. Move the 1 over, subtract it from each side. We get x is greater than or equal to -3. And x is less than or equal to 1. So look at this. This is an and statement, so we're going to have -3, x, and 1. Signs open to the x, signs open to the 1. On our number line, -3, -1, 1, 3. We are going to have closed circles on both the -3 and the 1. And then those lines are going to go in towards each other. For D, we have the absolute value of 10 minus 2k is greater than or equal to 6. We don't have to move anything over, so form your two inequalities. We're going to have 10 minus 2k is less than or equal to -6, and 10 minus 2k is greater than or equal to 6. So from here, get the k by itself. We're going to subtract 10 from each side. On this one, we have -2k is less than or equal to -16. Then we divide by -2. Since we're dividing by a negative, we switch the sign. So k is greater than or equal to positive 8. For the other equation, we're going to subtract 10 from each side. Inequality, not equation. We have negative 2k is greater than or equal to negative 4. We divide each side by that negative 2, and once again, since we're dividing by a negative, we switch the sign, so k is less than or equal to positive 2. We are going to rewrite these to where the 2 comes before the 8. Our signs point away from each other, so this is an or statement. On our number line, 2, 4, 6, 8, 0. We have closed circle on the 2. Our line goes to the left. Closed circle on 8. Our line goes to the right. For E, we have the absolute value of 4 minus x plus 15 is greater than 21. So we're going to subtract that 15 from each side. We get the absolute value of 4 minus x is greater than 6. From here, we're going to make two inequalities. So 4 minus x is less than negative 6, and 4 minus x is greater than positive 6. Subtract the 4 from each side. We get negative x is less than negative 10. Divide by negative 1. Change the sign. So x is greater than 10. For the other inequality, we subtract the 4 from each side. We get negative x is greater than 2. Then we divide each side by a negative 1. So x is less than negative 2. Look at the way that your inequalities are. The one that includes the smaller number is not first, so rewrite it to where x is less than negative 2, x is greater than 10. These two signs point away from each other, so it's an or statement. And then on our number line, so we are going to have, this is going to be negative 2, 0, 2, 4, 6, 8, 10, 12, negative 4. Okay, so open circle on negative 2, open circle on 10, lines go away from one another. For F, we have the absolute value of x plus 4 minus 10 is less than or equal to negative 2. So we're going to move the 10 over, add it to both sides. So the absolute value of x plus 4 is less than or equal to 8. This is a possibility, so x plus 4 is greater than or equal to negative 8, and x plus 4 is less than or equal to positive 8. Get the x by itself, move the 4 over, subtract it from each side, so x is greater than or equal to negative 12, and x is less than or equal to 4. So because these two signs go in towards each other, and the negative 12 is less than 4, and that inequality that includes the negative 12 comes first, we are going to rewrite this as an and statement. So negative 12, x, and 4. Sign is open to the x with the negative 12. Sign is open to the 4 with that one. So negative 12 is less than or equal to x, which is less than or equal to 4. On our number line, negative 12, 0, 4. We are going to have closed circles on both of these numbers, and then our line goes in towards each other. For G, we have 3 times the absolute value of x minus 7 is greater than or equal to 9. So start by dividing each side by the 3. So the absolute value of x minus 7 is greater than or equal to 3. Once again, this is a possibility, so we're going to have x minus 7 is less than or equal to negative 3, and x minus 7 is greater than or equal to 3. Move this 7 over, add it to both sides. We get x is less than or equal to 4, and x is greater than or equal to 10. So with these inequalities, we're going to have an or statement because our lines go away from each other. So on our number line, we're going to have closed circle on the 4, and the line's going to the left. close circle on 10, line goes to the right. For h, we have the absolute value of 2x plus 3 is less than 5. So form your two inequalities. 2x plus 3 is greater than or equal to negative 5. Greater than, not just greater than or equal to, greater than negative 5. And 2x plus 3 is less than 5. So from here, subtract the 3 on each side. We have 2x is greater than negative 8. Divide each side by 2. So x is greater than negative 4. For the other, subtract the 3 from each side. So 2x is less than 2. Divide each side by 2. X is less than 1. So if you see these two inequalities, the sign goes in towards each other. The negative 4 is less than the 1. The negative 4 is on the left, so we're good. So we're going to rewrite this as an and. Negative 4, x, 1. The sign is open to the x between that and the negative 4, so it stays open to x. The sign is open to the 1 between the x and the 1, stays open to the 1. On our number line, we're going to have negative 4. We're going to have 1. We are going to have open circle on negative 4. Line goes to the left. Open circle on negative 1, or on positive 1, line goes to the right. For example 2, we have a machine at a lumber mill cuts boards that are 3.25 meters long. It is acceptable for the length to differ from this value by at most 0.02 meters. Write and solve an absolute value inequality to find the range of acceptable lengths. So that absolute value inequality, we are going to have the absolute value of the length minus 3.25 has to be within that 0.02, so it's going to be less than or equal to 0.02. So because we're not multiplying or adding anything to the absolute value of this, we're going to have L minus 3.25 is greater than or equal to negative 0.02, as well as L minus 3.25 is less than or equal to 0.02. Move the 3.25 over, add it to each side. This is going to give us that length is greater than or equal to 3.23 meters. And your length is less than or equal to 3.27 meters. So with this, your two signs point into each other. Your inequality that includes the smaller numbers on the left, so that's how we see that. So we're going to have 3.23, we have L, and we have 3.27. So between the L and the 3.23, it's open to the L, stays open to the L. Same thing with the L and the 3.27, it's open to the 3.27, so it stays open to that. So this is saying that the cut can be no more than 3.27 meters and no less than 3.23 meters. For example 3, we are given that a box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary as much as 0.1 ounce. Write and solve an absolute value inequality to find the range of acceptable weights. So we're going to have the absolute value of W, because we're dealing with the weight, minus 13.8 is going to be less than or equal to 0.1. So we are going to form our two inequalities. W minus 13.8 is greater than or equal to negative 0.1, as well as W minus 13.8 is less than or equal to 0.1. Move the 13.8 by adding it to both sides. We're going to have W is greater than or equal to 13.7 ounces, and W is less than or equal to 13.9 ounces. So look at your inequality. It's an and statement, so 13.7 is less than or equal to W, which is less than or equal to 13.9.